In this video, we'll look at the intersection of data science and economics. By the end of this video, you should understand why an economics department like AREC would have a class in data science, and what's the distinction between correlation and causality, and why is that important to policymakers and economists. Lastly, you'll understand why looking at correlations might lead to bad decision making. So why do we have a data science course in an economics department? Economists are critical in formulating policy and making strategic decisions for businesses. But economics as a science acknowledges that humans are optimizers, which implies that correlations may not actually imply anything causal about their behavior. The distinction between correlation and causality is very important to economists. So why do we have a data science course at AREC? Agriculture, energy, and the environment are all data-rich fields. They're also important for the economy and human well-being. Policymakers want to be informed when they make decisions, and we make these decisions leveraging data. I really want to focus on the distinction between correlation and causality. It's very important for economists when we're thinking about formulating policy and making decisions to understand this difference. Often when we're making decisions, we're changing the status quo. We're changing something about the set of decisions that people might make or the implications of making those decisions. That means that looking at correlations can lead us to bad decisions. But why is that? I think this comes best by the way of an example. So suppose that I'm interested in the effect of watching these videos on academic performance. The first thing that you should ask yourself is, why do I care about this relationship? From my perspective, I want to structure my courses and the class requirements in a way that makes it most likely that all of the students succeed in the course. So what can I do to see if watching these videos actually improves class performance? First, I think it's important to think about the real question that I'm asking here. If I could get students to watch more videos, would their grades actually improve? And this is what I mean by a change to the status quo. I'm wondering how changing the behavior of students by making them watch more videos would affect their grades. So to summarize it in a sentence, does watching more videos cause the grades of students to improve? So how might I do this? Well, what I could do is count up the number of times each student watches a class video. If you're not aware, your professors can actually see this. But I could count that number of times that every student has watched every particular video, and then look at the relationship between that and the student's final grade. So in this graph below, I have some simulated data. This actually isn't real performance of students in my classes or the number of videos that they've watched. I just simulated this myself. But what you have here on the x-axis is the number of videos that student watched, and on the y-axis, their final score in the course. What do you think this graph tells us? I think it's pretty clear from this graph that students who watched more videos got higher grades. But what does that tell us about watching more videos? So clearly video watching is correlated with higher grades, but does this tell me anything about how watching videos actually affects grades? I really want you to think about this for a second. Why or why not? And in that context, if I made a student watch more videos, how would his or her grade change? First, I'll start out by thinking, how could this go wrong? So if all I see is the correlation between video watching and the final grade, I don't actually get an indication of how changing the number of videos a student watches would impact their grade. The fact is, students who don't watch a lot of videos are probably systematically different from those that do watch a lot of videos in ways that affect their grades. So students who are really good at this class and understand the content may not watch the videos, and they'll do well regardless of the number of videos that they watch. Conversely, students who don't need or don't value a good grade may skip the videos, but also other assignments in the class, and they'll do really poorly regardless of whether or not I try and make them watch more videos. There's another way that this could go wrong. Suppose a student in my class has watched too many National Treasure movies. And as a result, they think there's hidden messages in my videos that lead to lost treasure on campus. All they need to do is find the clues that are hidden in the videos. So they obsess and they watch my videos over and over again, looking for those clues. But after all that sleuthing, they're so tired that they don't do well on the problem sets. What would happen is a student watched a lot of videos, but still did poorly in the class. More importantly, if I were to somehow make the student watch more videos, they wouldn't have done any better. In fact, the videos were actually impairing their performance. So just looking at the correlation between the number of videos watched and class performance doesn't actually tell us what would happen if I changed the status quo, if I implemented some kind of policy that forced students to watch more videos. In the end, it's factors like these that make correlation a bad measure of the causal effect. Things that are going on in the background can influence both video watching and grades, but I don't observe those things that are going on in the background. So simply looking at the correlation doesn't actually tell me the true relationship if I were to change the number of videos that an individual student watched. When it comes down to it, large volumes of data and fancy data science tools can't help us overcome this problem all on its own. That's pretty depressing, right? This doesn't, however, mean that we can't ever know the causal effect of video watching on grades. Economists in particular, but many other social scientists, have developed a large toolbox of methods for separating correlation and causality. If you're really interested in these methods, and you should be, you should take AREC 422, which is Econometric Analysis in Agricultural or Environmental Economics, where they'll cover those methods in detail. But what I want to stress here is that making business or policy decisions based on correlations, as opposed to the true causal relationship, can lead to costly and ineffective outcomes. And remember, we want to use data to make better decisions. And I'll be honest, not every data scientist appreciates this. A couple of years ago, I came across this tweet from a data scientist. Very prominent, he has a big Twitter following. And he says, 3 of the very best data scientists I've met have no college degree. And while I generally observe almost zero correlation between data science skills and a formal degree, my sample size is small, but I'm still convinced that academic achievement is terribly overrated in our field. Now, what's the mistake he's making in this generalization? This person knows 3 very, very good data scientists who may be trained on their own, who are maybe very motivated, but they don't have a college degree. And so what he's saying is he doesn't observe correlation between data science skill and a formal degree. But because these people were very good at data science, they perhaps didn't need to go to college, or they perhaps exceeded their peers who did just because they're very good at what they do. That doesn't mean that there's no value to a formal degree. And again, looking at this correlation here might not tell us about the true effect of actually getting a formal degree on your data science skills. Through the years, I've seen many people make this exact same mistake where they confuse correlation and causality, and as a result lead to bad decisions. And in some cases, those have been very, very costly decisions for businesses, thinking that there would be some large effect from a policy change that actually had no effect. But these decisions wound up being very costly because the effect of the correlation was nothing close to what the actual causal effect was.